Howdy, getting blocked by the German Sysadmin challenge? Maybe you're stuck on handling Charlists or the pattern matching for sanitization. In this video, we cut through the confusion. We'll leverage an AI-guided structured analysis to instantly clarify exactly how to use case expressions and recursion to master Charlist manipulation. Welcome to today's exercise, German Sysadmin. Let's accelerate your mastery of Elixir's list processing power.
Hey everyone, and welcome. Today, we are putting on our sysadmin hats to tackle a really fun Elixir challenge from Exercism called German Sysadmin. You know, this is one of those great real-world problems. We're going to be cleaning up data, handling special characters, and really getting a feel for some core Elixir concepts. Let's dive in.
This exercise is a perfect gateway into the functional mindset because it presents data transformation as a series of immutable steps. The chart list is a powerful representation. It's a list of integers. That unlocks the potential of list manipulation and recursion in Elixir. In this challenge, we'll leverage the case statement for clear pattern matching logic. Mastering these building blocks now ensures your Elixir code is fast, concise, and ready for deployment.
All right, so let's set the scene. Imagine you're a sysadmin over in Munich. You're getting tickets because users can't email Mr. Mueller. Why? Because some ancient, super stubborn email client on the network just can't deal with that "oo" in his address. It sees Mueller@firma.de, throws its hands up, and just fails. Now, we all know that telling an entire company to update their software is a fight you're probably not going to win. So you've got a new mission. You need to write a script that can create clean, sanitized email aliases. We're talking about transforming those usernames with special characters into something that any system, old or new, can understand. It's all about keeping the communication flowing.
I've downloaded the German Sysadmin exercise using the Exercism CLI and then loaded it up into VS Code. I then ran our generate docs prompt that brings the instructions and some examples into the source code so that it's easier for us to target what the exercise is aiming for. When you see a char list, immediately think of it as a linked list rather than a string. This list structure is the key to unlocking recursion for iteration. By processing the head and passing the tail onto the next function call, you avoid mutable state and ensure that every step is transparent. Let's set up the recursion structure. So recursion, we handle the base case first, which is when we receive an empty list, we're going to return the empty list. We're going to pattern match on the username for the second function head. We're going to call out the first letter and then the rest of the string. And what's going to happen in here is we're going to do some amount of filtering on the head or the first character. And then we're going to concatenate that with the sanitized tail.
All right, our second essential tool is the case statement. You can think of it like a switch statement on steroids. It takes some value, and then it tries to match that value against a bunch of different patterns going right from the top to the bottom. As soon as it finds a pattern that fits, it runs the code for that pattern, and it's done. Character uses a case statement with guard clauses to see if its code point is in the A to Z range. And here's what we're aiming for. An input like Schmidt 1985 needs to come out the other side as just Schmidt. Our function would look at the S, see it's a lowercase letter, and keep it. Same for C, H, M, I, D, T. But then it hits the 1. Our guard clause says, nope, that's not a lowercase letter, so it just gets dropped, and the function moves on. It's a perfect little filter.
Let's start the case statement for the first instruction, which is to allow lowercase letters as in the username. So what we're going to do is we're going to have a case statement based on the first letter. And then we're going to say first, when first is greater than or equal to a lowercase a, and first is less than or equal to a lowercase z, then we want to return the first. One of the things the instructions don't really talk about much, and neither does the explainer video, is that we're going to concatenate with the tail. Now the tail is a list also, so in order to concatenate lists, we need to return a list here. We also here need to handle the case when it doesn't match that the first letter is between lowercase a and lowercase z. We don't want to return anything, so we're just going to filter it out. This will get rid of the numbers, for example. So then we would take and assign this to sanitized. And we can then concatenate sanitized with whatever we get from sanitizing the rest of the username.
Great! Our basic filter works. But let's be real, usernames have underscores all the time, and we definitely don't want to be deleting those. So, step 2 is all about making our filter a little bit smarter.
The new rule is simple. Underscores are now on the VIP list. They get to pass through our filter. To make this happen, we just need to add one more little check to our logic. Inside our case statement, we'll just add a new clause that explicitly looks for the underscore character. It's a tiny change, but a really important one.
And this slide shows exactly what we're going for. Our updated function takes something like super-duper Mark Fisher 000 and cleans it up to be Mark Fisher. See? The logic now correctly keeps the underscore right along with all the letters. But those $signs at the end, they don't match any of our allowed patterns, so they're still getting kicked out.
Let's add a case for allowing underscores. We simply say when first matches the underscore, we're going to return first. For efficiency, always place your most common patterns at the top of case expressions because clauses are evaluated sequentially from top to bottom. In this German Sysadmin scenario, the simple case for lowercase letters and underscores should be high up, followed by the less frequent German character substitutions, speeding up your function's execution on typical usernames.
And now, we've arrived at the final and, let's face it, the most important step. This is the one that actually solves our sysadmin's original problem. It's time to handle those German characters.
So here's the final tweak to our function. It's not just about keeping or dropping it anymore. Now we have a third option, substitution. This means our case statement is about to get even more specific, with brand new clauses to catch and transform each of the German characters we care about.
And this table, right here, this is our new rulebook. This becomes the brain of our operation. For every one of these German characters, we're going to add a special clause in our case statement. So when our function is processing a username and it sees the character "u", for example, it'll hit that specific clause and return the charlist C2UE to build into our final clean username.
Now let's handle those non-ASCII character substitutions. So we want when it matches an A umlaut, and what we could return from here is AE. And we could do the same for the others, and O umlaut is OE, U umlaut is UE, and Heise, I think is that character, is double S. So this sticks with the theme that we're always returning in a list, and it's obvious it's a list. You could alternately use the sigil, C sigil, and return the string UE like this. I kind of like the C sigil because it's clear that we're returning some letters. On the other hand, to the novice, it hides the fact that it's returning a list. Which do you like better? Let me know in the comments below. A key insight here is that you're not changing the char list. You're building a new sanitized one, character by character, which is the heart of immutability. Each list operation, whether it's filtering non-letters or substituting German characters, is a pure function that takes the old list state and returns a new one. This functional pattern makes your logic inherently safer, easier to test, and ready for parallel processing on the beam.
And here it is, the grand finale, everything working together. The name, Cassili Weiss, goes into our sanitizer. The A gets spotted and replaced with A. The underscore is kept, no problem. The B is matched and swapped out for SS, and the result is the perfectly sanitized Cassili Weiss. Mission accomplished.
So we did it. We totally solved the sysadmin's problem. But more importantly, what did we actually learn by doing this? Let's take a second to recap the big takeaways from this exercise.
So let's think about what we've really accomplished here. You've now seen exactly how to use char lists for that fine-grained character-by-character manipulation. You've applied the case statement for some seriously powerful pattern matching, and by putting them together, piece by piece, you built a data cleaning pipeline that solves the kind of problem you could genuinely run into at a job.
Mastering Elixir's character processing starts with understanding char lists as lists of integers. By combining the list processing power of Recursion With the clean, multi-clause logic of case expression, you can write concise, functional code that handles complex, real-world data validation. Embrace these fundamental patterns, and you will dramatically accelerate your journey towards professional Elixir mastery. Hit the like button if you learned something today, or to let me know you enjoyed the video. Subscribe so you don't miss out on more accelerated AI-guided walkthroughs that deconstruct complex Elixir challenges like this one. Dive into the playlist to continue building your expertise one powerful function at a time. See you next time.